Hello, thank you for watching this video and following the weekly sessions for QuickMathics. I hope this week has been great for everyone. And now, yes, let's continue to geometry. Last week we review a lot of things. We weighted average, um coordinates like midpoint, Um, all of that, basically. If I, yeah, like this is all weighted average. This is start the midpoint, and we basically left with a midpoint exercise. So today we'll continue working with that, and let's do exercise 11. Exercise 11 says find the coordinates of other endpoint of a segment with an endpoint of 13,5 and a midpoint of 8,3. This is basically of what um like the one we did last week, which was this one. So what I like to do in this kind of exercises is basically calculate the y in one side and the x in the other, basically separate them. So I know that our formula for the midpoint for x is going to be x1 plus x2 divided by 2 is equal x. The thing is that we already know the value of one of the x, one of the endpoint, and the value of the mid of the x of the midpoint. So we can just substitute this. One of the x for the endpoint is 13, so I can say that 13 plus x2 divided by 2 is equal, and I know the value of this x, which is the midpoint, in this case is 8. So I know that is equal 8. So we basically calculate using algebra here. We multiply each side by 2. So we cancel this 2 with this 2 and we get 13 plus x2 equal 8 8 times 2 is equal 16, so equals 16. And now we subtract each side 13, like 13 from each side, and we get like 13 minus 13 is 0, so we have x2 equals 16 minus 13 is 3, so x2 equals 3. Now this is for the x value. Now let's calculate for the y value. Wait, I'm just trying to make this look better. Okay, now for the y value is basically the same. So we have y1 plus y2 divided by 2 equal y. And we can just substitute the value y1. This one, the value of the endpoint, which is 5. 5 plus y2 divided by 2 equal the value of the midpoint is 3. So we can say equal 3. Now we multiply times 2 in each side and we cancel this and we get 5 plus y2 equal 3 times 2 6, and we subtract 5 from each side. I have 5 minus 5 0, and 6 minus 5 is 1, so we have, wait, let's trying to make this smaller. And this is a plus sign. I don't know why it looks like an X. So we get y2 equals 6 minus 1, 1. So our coordinates for the other endpoint are going to be x2 comma y2. In this case, is equal 3 comma 1. And this is going to be our answer. Now, point A is located at 6, 3. Point D is located at 18, 21. If point B and point C are located on AD, such as the ratio of AB, BC, and CD is equal to 1, 1, 1, what are the coordinates of point B and C? Now, this exercise might seem complicated, but it's easier than it appears. So let's do our line. We have A, we have D, and we have this line here. I'm trying to make here we go. And this is A and this is D. Now we know that somewhere in here is B, somewhere in here is C. We don't know exactly where. But the thing that we know is that AB, this side, BC, CD is the same to say 1 to 1 to 1, which means that each side is equal. Like AB is equal BC and BC is equal CD and therefore AB is equal CD. That happens because the ratio between those three is the same. So basically what we can do to know the coordinates of point B and C, I can call it a little bit of logic. So I want to know what is the average rate of change. I don't know if that's the correct name, but it's basically how much the exchange from here to here and how much the y change from here to here. So since they are three three segments, I can calculate first the distance between like all the end point and the start point. I'm gonna do x first, so I have like x2 minus x1, and I'm going to divide that distance by 3, which is the number of segments that we have. That is because I want to know how much the x change in each of these segments. So I'm going to use x2, which is 18. Oh, sorry. I don't know why that happened. So 18 minus 6 divided by 3. A minus 6 is equal to 12. I'm going to divide this by 3, and our result is going to be 4. So I know that from here to here, this is 6, comma 3. This is going to be 10, comma something. This is going to be 14, comma something. And this is finally 18, comma 21 because they gave us the y value. And that's because I know that in each of the segments, the x value change by 4. Now I can do the same with the y value. So I have the 21, like y2 minus y1 divided by 3. Now that the 21 is y2, so I know 21 minus 3 divided by 3 is going to be 18 divided by 3. Wait a second. And this is going to be 6. So I know that our y value is going to change by 6 each time. So here is going to be 3 plus 6 is 9 plus 6 is 15 and plus 6 is 21, the value we already have. So we already know our coordinate for B and C, and we go here, and when we see the options, our correct answer is going to be option B. And this is how we solve this exercise. Here we go. Now, 13. Point B divides the directed line segment from point A to point B in the ratio 2 to 3. The coordinates of point B are. Now, we have another line. This is going to be point A and negative 4,1. This is going to be point B at 6,4. And somewhere here, it's going to be point 3, point P. Now, the only thing we know now is that the ratio is 2 to 3. What this means is like when we have the distance from this side over the distance of this side, we're going to get 2 over 3 when we divide them. So I can say that this is going to be 2x, or I'll put 2z, so I don't use the x as a variable, and this is going to be 3c. Since the ratio is 2 to 3 starting from point A. Now, we can realize that our total value is 5c. So I know that we can divide this in 5 little pieces, each of them equal to each other, and they are C. So this is 1C, this is 1C, this is 1C, this is 1C, and this is 1C. Making this 2C, and this one, and this bigger one, 3C, with a ratio of 2 to 3. Now, if you realize there are 5 C's, so I can basically do what I did here. So each of these C's are going to have a ratio of 1 to 1 to 1 to 1 to 1. The only difference is that they are now 5. So I can do exactly the same as I did before, but instead of using 3, I can use 5. So this over here, I have x2 minus x1 over 5. And I can know the change of the x in each of the little segments. So x2 is 6, x1 is minus 4, so minus 4. Over 5. When we have two um negative signs together, it's going to be a positive sign. So this is the same as saying 6 plus 4 over 5, which is equal 10 over 5, which is equal to. So I know that the coordinate from this point is going to be like negative 4 plus 2, which is negative 2, comma something. This is going to be 0, comma something, 2, comma something, 4, comma something, and 6, comma 4, which we already have. Now we want to know the y coordinate. So we do the same. We have this is negative 1. I don't know what I put the positive one. So we substitute the values here. We have y2 minus y1 divided by 5. Y2 is 4 minus y1 is minus 1 divided by 5. They are both negative, so it's the same as a4 plus 1 divided by 5, which is equal to 5 divided by 5, which is the same as 1. So this is going to be negative 2 comma 0, 0 comma 1, 2 comma 2, 4 comma 3, and 6 comma 4. Now, as we can see, we already calculated the coordinate of point P, which is going to be 0 comma 1, which is option B. I hope you guys understood what I did. If not, you can always go to the score and ask me any question if you need it. Now for question 14 is the same, it's another ratio. We have the coordinate for both point A and point B, and we want to calculate the 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 coordinates for point K. So we have this is point A, this is point B, and this is going to be point K. Now the ratio in this case is 3 to 1, so I know these are gonna be 3 little segments, and this is going to be oops, and this is going to be only 1. So this is 1C, 3C, and this is 1C. Now we basically do the same, but in this case, in there are only 4 little segments, we divide it by 4. So we have x2 minus x1 over 4, x2 being 5, minus x1 minus 7, divided by 4. They were a negative, so it's the same as adding the numbers, so it's 5 plus 7 divided by 4. This is going to be 12 divided by 4. This is going to be 3. So I didn't put the starting coordinate here. This is negative 7,11, and this is 5, negative 5. So I know that the change is going to be positive 3 for the x. So this negative 7 this is going to be negative 4. This is going to be negative 1. This is going to be 2. I'm going to delete this, I put it later. And this is going to be 5. I'm going to leave. Negative 7 plus 3 is negative 4, plus 3 is negative 1, plus 3 is 2, and plus 3 is 5. Let me just put the k here. Now we want to calculate the y coordinate. So we do the same. We have y2 minus y1 over 4. I'm sorry. Y2 is going to be negative 5. Y1 is 11 divided by 4. They both have the same sign, so I just add them and keep the sign. 11 plus 5, 16, so negative 16 divided by 4, and this is going to be negative 4 because they have different signs, so we want to keep the negative. Like always they are different signs. Our result is going to be negative. Always they are equal signs. It doesn't matter if they are both positive or both negative. Our result is going to be positive. That's always true in multiplication and division. Adding and subtracting they go by other procedure. So we go that our change in the y is -4. So we go here, we have 11, -4 is 7, -4 is 3, -4 is -1, and -4 is -5. So we just calculated that the coordinate for point K is 2, comma, -1, which is choice A. Now, okay, this question 15, is basically the same as question 13 and 14, but I'll do it anyway because these are one of the trickiest questions of the exam that many times confusing students. So let's do it again. So we have the segment, and we have point R divides a line segment with endpoints P 4,5 and Q 10,14. So we draw the line segment, and this is P, which is 4,5, and this is Q, which is 10,14. In the ratios such as that PR to RQ is 1 to 2. So we know that this is going to be, I change the color. This is going to be 1 liter segment. This is R. And here we're going to find 2 segments. Now we keep using the same procedure, x2 minus x1 divided by 3 in this case because there are 3 liter segments in total, like 3 C's, as I like to call them. And x2 in this case is 10 minus 4 divided by 3, 6 divided by 3, and 6 divided by 3 is 2. So the change in the x is going to be positive 2. So this is going to be 4 plus 2, 6, plus 2, 8, plus 2, 10 that we already had. Now the change in the y2 minus y1 divided by 3, y2 being 14, y1 being 5, by 3, so this is 9 divided by 3, and this is 3. So the change in the y is positive 3, so 5 plus 3 is 8, 8 plus 3 11, and 11 plus 3 14. So we know that point R is going to be 6, 8, as we already calculated. And so choice A is our answer. Now for 16. A highway connecting two cities is represented on the coordinate plane below. The highway has two rest areas along the route, such as they divide the distance between the cities into three equal parts. Now, in what ratio does the rest area closest to the city A divide the distance from city A to city B? Now, we know that these two rest areas are going to divide the distance between the cities and the like the distance between the cities into three equal parts. So I know that. So I'm not going to make like exactly as like the exact point. I'm just going to make it approximate, I think. So I know this is equal. This is D. This is D. This is C. This is the first, like the first rest area that I will call um rest 1, and this is the second rest area, which is rest 2. Now they ask, In what ratio does the area closest to city A, which in this case is going to be R1, divide the distance from city A to city B? So this is kinda easy if you see it this way. Like you can see right now that from A to R1 we have 1C, while from R1 to B we have 2C's. So our ratio is going to be 1 to 2 because here we only have one space and here we have two segments, like one segment and two segments. So our ratio is going to be 1 to 2. Now, what are the coordinates of the point representing the first rest area? To calculate this, we just need to do what we already did before. X2 minus x1 divided in this case by 3, since there are 3 equal segments. So we need to go here to the graph. We see that x2 is going to be 1 minus x1 is going to be minus 5. Those negative sides converting to positive, so 1 plus 5 divided by 3, 6 divided by 3, and this is equal to. So our change is going to fit in, our change in the x is going to be 2. So this is going to be negative 5 plus 2, going to be negative 3, and negative 3 plus 2 is going to be negative 1, and plus 2 is going to be 1. Now we need to calculate. I put this in another color because it's kind of confusing right now. Wait, so you guys can see it better. Another one. Give me 1 second. Better. Negative 3 common, and this is negative 1 common. Now we want to calculate the y. So y2 minus y1 divided by 3. Y2 here is going to be 5 minus y1 is going to be negative 4. They are both, this is divided by 3. I put this all to the side. This is a little more. So this is going to be 5 plus 4 divided by 3, which is 9 divided by 3, which is equal to 3. So the change in the y is positive 3. So negative 4 plus 3 is negative 1. And negative 1 plus 3 is 2. So our point is going to be negative 3 comma negative 1 and negative 1 comma negative 2. But since they are asking for the coordinates of the first rest area, or result is going to be R1, so it's going to be negative 3 comma negative 1, which is choice A. Now, what are the coordinates of the point representing the second rest area? We already did it. Since we calculated both, so result for R2 is negative 1 comma 2, which choice C. If a device, part D, if a device station is built halfway between the rest areas, what are the coordinates of the point representing the service stations? Since we already know the coordinates for point A, for the rest area 1 and the rest area 2, we can just calculate the midpoint, which is the formula we used before. I'm going to do it right now. This is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So we substitute this. We have like our coordinate, or y1 is going to be, x1, I'm sorry, is going to be negative 3. So negative 3, comma, x2 is -1. Oh, plus -1 divided by 2, comma, or y1 is going to be -1 plus, or y2 is 2 divided by 2. And they have equal signs, so we add them and keep the sign. So -3 plus -1 is going to be -4, and this is over 2, comma. They have different signs, so we subtract them and we keep the sign of the bigger one. So 2 minus 1 is 1, and since the 2 was positive, or 1 is also going to be positive, so 1 over 2, and this is going to be -4 divided by 2 is going to be -2, so the signs are different, so our result is going to be negative, and 1 divided by 2 is 0.5. And this is our result for this calculation, -2, comma 0.5, 0.5, which is choice B. And it is right here in the graph. Yeah, right here. Now, this is a new formula that I haven't discussed before. This is the distance formula. It's very important not only now in geometry, but later when you keep studying mathematics in pre-calculus. I could algebra 2 especially. I could even say calculus later on, and you're going to use it like very much. Also in physics is important, sincerely. So basically it studies the distance formula is equal is square root of x one plus, wait, no, it's x2 minus x1 square plus y2 minus y1 square. I'm going to check that right now just to make sure I'm doing it right, since I haven't, yeah, since I haven't like do this in a long time. Um, so in this case, we just substitute the values. I really mean like you need to memorize this formula. I'm 90% sure that you're going to get the formula sheet in the exam, not physically, but the platform, or at least the one I used 2 years ago. You can click a button and you're going to get like the formula sheet for the distance formula, midpoint, other formulas, but I'm not sure if they are keeping that right now. I could like research later. But I really recommend to memorize these formulas if you can. So we have this formula, we have the point, and we just want to know the length for this, so the distance. We substitute it with x2, which is 3, minus x1, which is -2, square, plus y2, which is 1 minus y1, which is 7 square root. Now this is going to be equal square root with minus minus, we say that is plus, so 3 plus 2 is going to be 5, so it's 5 square plus 1 minus 7 is going to be the bigger minus the smaller, and keeping the sign of the bigger, basically. So 7 minus 1 is going to be 6, but since our 7 is the one that is negative, our result is also going to be negative, so -6 and square. We calculate this is a square root of 25 plus 36 times 5 times 5 is 25, 6 times 6 is 26. Wait, negative 6 times negative 6 is 26. Is 36 positive since they are both negative, so they have the same sign. And as I explained before, if two numbers that are multiplying or dividing have the same sign, the result is going to be positive. So we add them. Move this a little bit to the side. We add them and we get that d is equal a square root of 64. No, is 61. Wait, it's 61. I just want to make sure. Yeah, then the square root 61 doesn't have like any specific value. So we could either put the square root of 61 if we want to be specific, or just put it in our calculator and see what is the specific value, which is 7.8 approximately, which is approximately 7.8. And this is our answer. Right now, I'll do exercise 18 and 19, maybe 20 if I have more time, but let's just keep going. Now, for 18, segment PQ has endpoint at P negative 5,5 and Q 2.5, negative 2.5. What is the length of PQ? And this is all again the Dyson formula. So we just put the formula right here and copy. Let me see if it's letting me now, since when I was doing algebra it didn't let me. Yep, copy. I'm going to substitute the values. In this case, is x2. x2 is 2.5 minus x1 is minus 5 square plus negative 2.5 minus 5 square. Now I calculate it and I got a square root. Minus minus is plus, so 2.5 plus 5 is 7.5, so 7.5 square. This is negative 2.5 minus 5. They have the same sign, so we just add them together and keep the sign. This is equal negative for 7.5 squared. So I'm just going to calculate 7.5 times 7.5 on my calculator, and I got 56.25. So I got that d is equal to square root of 56.25 plus 56.25, which is the same as square root of 112.5. Let me check that. Yep, 112.5, which is approximately going to be like 10 point something. Approximately is going to be around 10.5. Let me see. Yes, 10.6, as you can see. Oops. As you can see here. So our result is going to be approximately 10.6. So I either can put a square root of 112.5 or approximately 10.6. Now, for question 19, triangle ABE is shown below. Select all the true statements. Now, we see, oh, I'm sorry, let me go back. Here they are talking about the midpoint of BE, attacking the midpoint of AB. So we want, like, if we see it, we see that it appears to be the midpoint, but we can never assume that it is without calculating. So we can see we need to calculate the midpoint of AB, and we need to calculate the midpoint of BE. So so let's do it. I'm going to calculate it right here for BE. This, yeah. I have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is the formula for midpoint. Now for BE, it is x1 is 6 plus 9 divided by 2, comma, the y is 7 plus 1. 7 plus 1 divided by 2. And this is 15 divided by 2, comma, 8 divided by 2. So this is 7.5, comma, 4. And we see that actually 7.5 is approximately here, and 4 is here. So H is indeed the midpoint of B. So this is a true statement. Now let's calculate F. Now here we have the same formula. I'm not going to write it again. Our x1 is going to be 1, x2 is going to be 6 divided by 2, comma, 3 plus 7 divided by 2 is a 7. And this is going to be 7 divided by 2, comma, 10 divided by 2. This is 3.5, comma, 5. So 3.5 is approximately here, and 5 is here. So F is indeed the midpoint of AB. This is true. Now, you want to calculate the length of FH to see if it is 4.1. So we want to use the distance formula. Let me put this smaller so it doesn't like occupy space in the bottom part. Now let's calculate the distance for FH. So here we have F, and here we have H. So we have our distance formula. I'm going to substitute everything like directly without writing the formula, since it is like right here. And I have my x2 7.5 minus 3.5 squared plus 4 minus 5 squared. This is equal 4 squared plus -1 squared, which is gonna be a square root of 16 plus 1, which is the same as the square root of 17. And if we go to the calculator, it's going to be around 4.1. So yes, around 4.1. So this is approximately 4.1, and our answer on this is correct. Now, AV is equal to AE. Now, for this one, we need to calculate both the length of AB and the length of GH. So the length of AB is going to be using the distance formula. I really don't have that much space right now, so I might move this over here. Oops, move this. Oops, move this over here, so I have a little more space, and I can calculate AB and GH. Now AB, we use the same formula again. So AB is 2 is 6 minus 1 square plus 7 minus 3 square, which is equal to square root of 5 square plus 4 square, which is going to be 25 plus 16, which is going to be a square root of 41, which is going to be approximately 6.4. Now let's calculate the age. The age, we're going to use the same formula. I put it here. X2 is going to be 7.5 minus 5 plus, I make this smaller so I can keep working. But this is a square plus 4 minus 2 square, so we get 2.5 square plus 2 square. This is going to be 6.25. I don't know, wait. Yeah, 6.25. Square root of 6.25 plus 4, which is the square root of 10.25. This is going to be around 3.2 square root of 10.25. Oops, let me put it again, which is around 3.2. And we actually see that AB is 6.4 and GA and HH is 3.2. So 2 times HH, 2 times 3.2 is actually 6.4. So D is also true. Now, BG is a perpendicular bisector of AE. Now, BG is this one. To be the perpendicular bisector, this has to be perpendicular and G has to be the midpoint of AE. We also actually need to calculate if G is the midpoint of AE. So to calculate the midpoint, as we already did before, I'm going to do it right here. It's going to be 1 plus 9 divided by 2, comma, 3 plus 1 divided by 2. This is going to be 10 divided by 2, comma, 4 divided by 2, which is the same as 5, comma, 2. And yep, G is actually the midpoint, so now we need to see if it is perpendicular. For an equation to be perpendicular, like the slopes of the lines needs to be opposites and reciprocal, which means that if the slope of one line is A, the slope of the other needs to be negative 1 over A. This is basically the rule. Let me put in another highlight so it's easier to see. Basically this. So we let's calculate the slope. I hope that you guys know the slope formula, which is m equal y2 minus y1 over x2 minus x1. So let's see for BG going to be equal like m for I put it here m for BG is going to be equal y2 is 7 minus y1 is 2 over 6 minus 5. This is going to be 5 over 1, which is the same as 5. Now for the slope of AE, slope of AE, like, yeah, is going to be 1 minus 3 over 9 minus 1. This is going to be negative 2 over 8, which is the same as negative 1 over 4. As we see, their slope are not for reciprocal opposite, like they're opposite but not reciprocal. For AE we perpendicular with BG, its slope must has been 1 over like negative 1 over 5. For BG to be perpendicular to AE, its slope must has been 4, which is was not the case, so B is false. It is a bisector, but it is not perpendicular. Now, the medians of triangle ABE intersect at point um 5.3, 3.7. The median is basically the line that goes to the point of the bisectors of the like it's not a bisector, it is another one. Like to the angle, the point to the midpoint of the opposite side. So it's going to be A to H and it's also going to be E to F since they are all the midpoints. You can see like this drawing like doesn't reflect the start point for the tree. It's just that it's like kind of difficult to make it work. Actually graphing. So by visualizing the graph, I could say that yeah, it is indeed true since like 5.3 is actually going to be like around here and 3.7 is going to be around here. And we don't need like an exact calculation to actually prove it since it is like we can visualize it very well in the RAM. So this is true as well. So one more thing, I'm going to check that I remember the medians of the triangle, right? So I'm going to build here median of a triangle, median of triangle. And yes, is the vertex, is the segment that connects the vertex to the midpoint of the opposite side. So yes, this here is true. And the only false is going to be E. And that's all for today. I'm sorry that this video was a little bit longer than usual, but I needed to finish with question 19. So next week we'll start with question 20 and keep going for this like really long chapter. Thank you. Have a great week.